Hi, yeah, so my name is James, and Felipa and Anna invited me to come speak. I understand this program's a mix of um, creativity and computer science, so I'm just going to talk about my background and my kind of abridged history of this field and a couple of projects that I've worked on. So hopefully it's relevant to you guys. Like Felipa said, I studied computer science at the University of Toronto, and then I got a BFA in experimental animation at Cal Arts over in Valencia. So I have a mix of the creative and engineering background. After school, I ended up doing a lot of Flash, which I don't know if you guys have heard of because it's kind of a dead technology at this point, but I worked at Zynga on their poker game for a while. I did a lot of interactive games and design for ad agencies, and I also did a lot of print design, and then that sort of morphed into a large-scale interactive installation work. And then currently for the last 3 years I've been working at Adobe, first contracting in their research department, and now full-time as a prototyper in their design organization. And I'm going to talk about that at the end. So thanks for having me. So one of the earliest exposures that I had to interactive installations and immersive art was this work by Carl Sims, and this was in 1997. So this was when I was in high school, and he was working at MIT. He had access to one of the very first parallel processing computers at the time, and he had this really original idea to evolve virtual organisms and have them compete, and then he would sort of design these virtual organisms based on who would win these competitions. And when I was in high school, there was a museum installation at a museum by where I lived in Massachusetts, where he had these monitors set up, and you could step on the different. There's a picture down here. You could step on these different foot pedals, and it would evolve new creatures in front of you. And in 1990, kind of blowing my mind, and that kind of set me on the path. I think, looking back to where I am now. So I was just going to talk. This might be a repeat for some of you. So the other big inspiration for me was Flash, and this was like the first coding environment where designers could do coding, and that you could really easily code interactive graphics without a whole lot of background in pixels or bytes, or it was very easy to create procedural graphics and interactive graphics. And these are images from a book called Masters of Flash, which is a pretty interesting book, and it was a bunch of designers that were using math and code to create graphics and animations. And some of the big names were Joshua Davis, Jared Tarbell, Mario Klingemann, this guy Hugo, and I think a lot of people throw around the word creative technologist these days, and I think this was sort of like the origin of that culture in a lot of ways. This was like in the 90s, and this was like sort of the original creative coders, I would say. And I think it's kind of a forgotten past, because when a lot of people think about Flash, they think about really annoying intro screens and like just really bad UX, but I think there was like a really creative movement that doesn't get a lot of historical perspective, so I would recommend checking it out, definitely, for some inspiration. So this might be a repeat, but this is just sort of my abridged version of the history of HCI, or human computer interaction. One of the biggest events in sort of personal computers was what's called the mother of all demos, and this was a talk given by a man named Douglas Engelbart in 1969. It was the first use of a computer mouse. It was the first demo of video conferencing and collaborative workflows. It was one of the first examples of interactive text editing. It was kind of groundbreaking. It was just one single demo for, I don't know, maybe an hour and a half, and it was basically, he laid out everything that we used for like the next 30 years. So you can see here they're using a mouse to control a cursor, and this was like just kind of groundbreaking at the time. Later on, he shows copy and paste. He shows like databases for organizing concepts. So that kind of set the standard for the next 30 or 40 years of this metaphor of mouse, screen, keyboard. And this is a picture of the Xerox Star, which was famously ripped off by Steve Jobs for the original Macintosh. It was a research project at Xerox, and Steve Jobs went and visited it. And this is sort of what we were stuck with for a very long time. This is the 80s, and up until around the mid-2000s, when a man named Jeff Hahn showed a prototype. He did a TED Talk where he showed a multi-touch display, and this was one of the first. I mean, I'm sure there were other like research displays, but this was one of the first examples of manipulating simulations and graphics directly with their hands on a screen. This is before the iPhone. And this was both, for him, it was both the software and the hardware. So the way that it worked was there was a transparent piece of glass that he would shine LEDs through. And then when you stick your hands on the glass, the LED light would reflect off your fingers. And you can kind of see that in this photo. And so you would get these white blobs, and then there would be a camera that would be tracking those white blobs. And so you would have this 10-point interface. So it would basically be like 10 mouses, and you're interacting directly with the screen instead of indirectly, where you have a mouse here and a screen here and you're controlling a virtual cursor. So this was kind of like, to me, the first big breakthrough after this desktop metaphor of like mouse, screen, keyboard. And this was 2006. So at that time, this is pre-iPhone. And if you wanted to do these sorts of projects, you would basically have to develop your own systems. So you would have to have your own computer vision software. You would have to have your own, projection or display technology. You would have to build it all out yourself. So this was pretty sci-fi at the time, but there were companies that were doing it, and I ended up. So once Flash sort of seemed like it was over, I started trying to figure out what to do next, and that's a common thing I think in this field, is that it changes really quickly, and computer language can go out of style for whatever reason within a couple of years, and you have to constantly be learning. So I sort of started learning about 3D computer graphics and OpenGL, and getting away from just like simple 2D graphics. And this was one of the first sort of large-scale interactive pieces that I got to work on. And it was a interactive entertainment room for a private yacht. It was kind of crazy, but there was an interactive bar that was a touch screen. It would also react to cups that you put on it. There was sort of like fluid simulations. You could take photos and load them onto the bar, and then you could flick them onto this giant interactive wall and then present them to other people. And then there was an interactive dance floor. So these were sort of some of the earlier custom large-scale touchscreens. And these are all LED tiles underneath the bar and on the wall. So there were probably 5 different computers all rendering the single experience. So that was another specialty of mine, is multi-device applications, where you're rendering 7,000 pixels across, and it has to be interactive rates, 30 frames per second, 60 frames per second. And so these are very, very custom systems, because a lot of video games or typical applications are just, one single screen, maybe 1920 by 1080 at the max. At the time, probably 720. And then this piece, a private yacht. It was a pretty unusual project, and I worked on that for about a year. And this was sort of like my first step away from the web and working on, this idea, away from this screen keyboard metaphor and more about like, what does it mean when we're interacting with the spaces around us in a physical environment? And, what does it mean? So like when you walk in front of this wall, there's cameras that detect your motion and then the graphics react to it. So what does it mean to have like an immersive environment where the entire room is reacting to your movement or reacting to your touch, and you're able to put your own data into it and then manipulate it as if you're manipulating a physical photograph. And this was 11 years ago, and I think it still kind of stands the test of time in terms of the fidelity of the graphics. Another project that I worked on, this was for the water department in San Francisco. This is a 70-foot wall. There's 10 computers driving it, and it's in their lobby. It's a curved wall, and then there's 2 camera systems that are tracking people's movement. And when they walk in front of the screen, so there's no touch in this because it's a public lobby. So the idea here is that it's a sort of ambient experience. So you can either ignore it, you can walk through the lobby because it's a functional space, or you can go and you get these pop-ups, and it sort of tells the story of the water system, because San Francisco has a unique water system where they bought a reservoir, they bought a piece of Yosemite and they dammed it, and it's called the Hetch Hetchy, and so all of San Francisco's water gets piped via gravity down to the city. So this is an interactive mural that sort of shows how the water comes down from Yosemite, gets filtered, and then reaches the city. So as you walk across the mural, you see the story be told. The other aspect of this is that's interesting is telling stories through data. So how do you use data to tell a story? So I worked with the engineers in the water department and the waste management department, and we talked about they have a lot of sensors throughout their water system saying like how much rainfall each reservoir is getting, what the current levels are, how much energy is being produced by the hydroelectric systems. And so I worked with them to create these reports that would be updated every 10 minutes, and we created these data visualizations that would show live like how much water is in the reservoir, how much rain, and then also how much energy is being used in the building, because it's a platinum building, which means that it's a very environmentally conscious building. So the idea was we could show how much energy is being used on each floor, and then maybe that would like incentivize people to be like to not use as much energy and maybe create some sort of like competition between the floors. The other aspect is there's a media wall functionality where the photographers and artists could create imagery that can be shown on some sort of schedule. And the idea was this was because when you have a display system this high, hard to find artists and creators that can create content at that resolution. So we come up to create interactive experiences that don't require, rendering out video at 10,000 frames across, because it's just out of reach for most artists. So we created the system where artists could create 2 images, and that's a lot easier to create at those resolutions. And when you walk in front of each section, it would swap out that image. So it's still interactive, but it's not. It doesn't have the heavy workload of a video. So this is sort of like the intersection of design, computer science, just being able to program and display this and have it run 24 hours a day, and then also having the camera tracking system, which has to track people along a curved surface. So there's some math to figure out, if the person is in this part of the room, which part of the wall are they probably looking at, and like figuring out the angle on the curved sections. So a lot of interesting things. And this took me. I spent about a year working on this project. These are sort of the storyboards, trying to figure out, which parts of the water systems we want to illustrate, where are the animations going to be. So there's little animations of like the electricity running through the wires or the water running through the pipes, and then there's these videos that give you information about the building and the water system. So this was another project that I did 8 years ago, and this was for the Facebook Developers Conference, which is called F8. I believe this was the conference that they unveiled the like, which now sounds so obvious, but at the time was like button, and people could put the like button on their website or anywhere, and yeah, Zuckerberg spoke. So the interactive installation that was on the show floor. And every attendant had a RFID on their badge, and so there were 4 projectors on the ceiling that would create this one big mapped space. And the concept was like, what would a physical manifestation of a social network look like? Like, what would a social network look like in a physical space? So there was also a projector up above showing stats about the space. So when you enter it, you swipe into an RFID booth, and then the computer vision system would track you, and it would associate your data with a circle on the floor. And these circles are a graph showing a breakdown of your likes, like by like movies or books. And then if you and another person in the space have a like in common, have a similar interest, it would draw a line connecting you. And that's what all these lines are between the circles. And then if you get close enough, it would show you like a picture, an icon representing like, oh, well, these people have music in common, or these people have a television show in common. And there's some interesting UX about this. So the computer vision system would get confused if people got too close. So if people get too close to each other, we have the circles go away. And that sort of like encourages people to step back and be away from each other. And so this is sort of like a design solution for a technical problem, which is a common thing that you have to do, because a lot of times technology doesn't work exactly like we want it to. And a lot of times the design solution is actually a much easier way to accomplish the goal. And I believe, we did this whole project in about 3 weeks. So there was a lot of not sleeping. You can see a very tired me walking around in my hoodie. I think we got about 2 hours of sleep before this event. The other interesting thing is that it would these numbers on the screen would change. So it would say like, there's 1,000 likes in the space right now, or there's 200 people that like movies in the space right now. So it's sort of like a real-time visualization of the aggregate data of all the people in the space. And then on the technical side, just one of the things about interactive simulations or procedural graphics is that at any time there could be 4,000 things in common, there could be 10,000 things in common, and your system has to be able to draw that many lines and be real time and not look like it's stuttering. So all this is done through shaders and GPU programming. It's spread across 2 computers and 4 projectors. So the projectors are blended together to create one single image, and then the data is all shared between the 2 systems. So it's another example of multi-device programming. Alright, it seems to keep wanting to go out of full screen mode, but I'll just do that. There we go. So going back to like human-computer interaction and history, I worked on a lot of these interactive installations, but they require very large budgets. You need to have a very expensive client like a Facebook to be able to shell out all the money for the projectors, the camera systems, the computer playback systems. So when the Oculus, probably you guys have all heard of the Oculus for VR, was one of the first consumer VR systems. Before that, it was all done, in research labs with big bulky hardware. And this was something that you could buy for, $1,000 or something. And you have, to me, the thing that was really exciting about it was that you could create these interactive, immersive spatial experiences without all of this hardware. So you have like a full field of view, you have stereo vision, you have, not in the earliest incarnation, but later you have controllers that allow you to manipulate objects in space. So the thing that I was excited about was like we can create similar experiences to these like room scale installations, but like on a smaller budget and like on a personal scale. And I think in the industry there's a lot of debate and talk about virtual reality versus augmented reality and which is better, and I think that a better way for me of looking at it is as a spectrum. On one side you have just regular reality, and on the other side you have virtual reality, and going between there you have augmented reality and what this person Paul Milgram calls augmented virtuality. And this was one of the first kind of academic looks at this field of virtual reality and augmented reality, and I think he coined the term augmented reality. And so to him, this middle part between a completely virtual environment where everything, your whole experience is being run by a computer and everything is simulated, to versus you just, the physical world. There's augmented reality and augmented virtuality, which didn't really catch on as a term, but these are sort of called mixed reality now. So augmented reality, we probably all have heard of like Pokemon Go, and this idea of like putting virtual objects into the real world, either with glasses at some point or on your mobile phone. And then augmented virtuality is more you're putting real objects into the virtual world. So you might have some virtual environment, and then you stick like a video feed of the person inside of it, so it looks as if that person, almost like the visualizations you see on the Weather Channel or like really advanced green screens. So this was like a kind of interesting history point in HCI. And when the Oculus came out, I sort of pivoted a little bit away from interactive large-scale installations to immersive installations using VR and AR. So one of the first installations that I did was, or one of the first VR experiences I did was this, just this game called Orbigon, and it's sort of like a 3D version of the Simon game. I don't know if you guys are probably too young, but there's this game called Simon where you have to, where the four corners of the device light up in a certain sequence, and you have to recreate the sequence by tapping on it. So instead of a flat surface, this is a sphere. And using a device called the Leap Motion, which is a small camera that allows you to track your hands, you could rotate the sphere, and then you have to basically repeat the pattern that plays. So you rotate it around, and then you push the different colored sections in the right order. So this device would get mounted on the front of the VR device. And this is showing like the two views is the left eye and the right eye. So you get a sense of depth from it. And this was on the Oculus DK2, which is, so Oculus was a company started by this guy, Lucky Palmer, who's like, I don't even think he went to school. But he ended up selling the company to Facebook for $1 billion, and now Facebook has taken it on. And this version of the device was before, it was one of the most successful Kickstarters, and this is before Facebook bought it. And they had no controllers, so that's why we ended up using this hand tracking. So you get the video from the hand tracking device, so it's sort of like you're still in the world, this ghost image of the world, but then you're manipulating this virtual object. So another VR project that I worked on, so I ended up contracting at Adobe in their research department, and I worked with, they have an artist in residence program, and the artist was working on this virtual reality drawing app. And they hired me to help him develop it, and I ended up working on that for a year and a half. This is just a little example of me using the app. This is actually without the headset. So this is I'm looking at a screen, and there's a camera, and then I have two controllers in my hands, and I'm painting in the space while looking at the screen. So it's sort of like a mixed reality setup as opposed to virtual reality. And I don't know if you're familiar with, there's a program called Tilt Brush, which is a really popular painting app for VR, and this is similar to that, but it allows you to bring in brushes that you create in Photoshop. So these are all based on scans of basically artists putting down wet brush lines and then scanning them and creating virtual brushes out of them. And the VR painting is an interesting medium because it's somewhere in between sculpture and drawing, because you're using these sort of ribbons in space, but you're doing it in a 3D form. So you're not drawing on a 2D surface, but you're not sculpting like clay. So it's actually kind of a unique medium. So I worked on programming this for a year and a half, and we explored lots of different avenues with it, from one person holding their phone to see another person while they're in the headset drawing, to having camera feeds, to just all sorts of variations. So in this instance, I'm using a depth camera, which allows me to walk in and out as if I'm inside the drawing, even though I'm just in front of a camera. So that adds like this immersion layer to it. So there's a sensor that's like figuring out where the person is in the space, and then where they are in relation to these virtual paint strokes. And then you can use the controllers to manipulate the drawing by either scaling it up or down, or moving it around, and choosing different brushes and colors. And this ended up being just a research project. So after I was done with that project, I ended up working there. Oh, and these are a couple of paintings that I did with them. And these are basically drawn in VR and then exported and rendered in another application. But I think it has an interesting kind of painterly look that you wouldn't necessarily think it was done in a totally digital system. So then I started, Apple came out with their software AR Kit, which is what powers Pokemon Go, and it basically allows your phone to understand the world, the scene that it sees. So if I point my phone at these tables, understand that these are planes, and then I could put virtual objects on these planes, or it would understand that that's the floor, and it allows you to kind of place virtual objects inside your real world through the camera. So I ended up working with this man, Russell Brown, who's one of the original creative directors at Adobe, and he had an idea to create these simulations of weather systems for art installation. So I came up with these particle systems to help him do that. And one of the difficult things is documenting this work, because you want to give the sense of immersion as opposed to just, somebody looking at their screen. So I have to re-render all this content and then track the video and place the content so it looks as if it's in the world around the people as opposed to just on their screen. And that was actually one of the harder parts of this project. So this is basically like a design expression of fire, rain, wind, and the earth is represented by this geometric pattern on the pedestal. So people would walk up to the pedestal and then they would trigger these animations and they could kind of walk around the space and explore them, and there was spatial sound that went with it. And these are all real right now in something called procedural graphics. And this is kind of an example of that. It's never the same graphics, each time you see it. It's more of a system that has parameters. So you would have like the gravity or the amount of wind force. And instead of traditionally a designer would, draw by frame or in some 3D animation program a pre-recorded sequence, and then that sequence would just play like over and over again for each person. But in this sense, it's actually starting with like a random seed. So each time it's never exactly the same, but it's the same experience, but it's never the exact same effect. And I think that's a big trend right now in the industry, this idea of procedural graphics. And I think there's a lot of different reasons, because you can come up with a lot of variations of ideas really quickly, because instead of saying, I want this pixel to be blue, you say, I want these objects to respond to these forces. And you can kind of alter the force and come up with a completely different look in a matter of minutes, instead of spending weeks or months redrawing the whole thing. And then as we get more about spatial computing and having applications interact with your environment, it's really important that we don't have these stock assets. We want to be able to point at this desk and say, I want the character to be this wide. And so instead of having a stock 3D asset, you would have a system that defines that character, and it's flexible to different situations. And I think that's going to be a really big thing in the next decade. And this was part of an art show called the Festival Impossible that Adobe sponsored last year. And so they hired me to help with this, and then after that they decided to hire me full-time, which was great. So now I work in the design org as a prototyper, and the role of the prototyper is to quickly work on features for a product outside of the larger product team. So to sort of validate ideas quickly before they're actually integrated into a product. Oftentimes when you have a team of engineers and designers and project managers, they're looking at things a year or 2 years in advance, and they don't have the flexibility to kind of quickly validate an idea. So the idea here is to have a small group of people that are, not necessarily building out the entire application, but just a little small version of the application that is like a specific feature, and you can really quickly, because when you're looking at a static design, it's really hard to know, like, is this going to work when it's actually in an app, and especially with augmented reality where the application is totally different whether you're outside or inside or in the dark or in the light. And it's really hard from a single static design to tell, is this going to work? So I've been prototyping on some of the augmented reality applications at Adobe. And one of the ones that I was just going to talk about the process from a recent project that I worked on. So this was a research project using deep learning and neural networks to drive animated character. And in this particular case, a four-legged or quadruped character. So this wolf is not animated by animator, but is actually taken from motion capture data or animation data that was like, you know, there's maybe like a jump animation and a run animation and a walk animation, but they're not necessarily put together into this final sequence. It's the network that ultimately does that. And this was research work that was shown at the SIGGRAPH conference last year, which is a very famous big computer science graphics conference. And this also kind of fits into the idea of procedural graphics. So, you know, what if an animator didn't really have to, you know, hand animate each leg motion? What if they could just say, you know, I want the character to walk over here, and I want them to walk over here and stop. And I think, you know, it gives a lot of flexibility to designers and creative and artists to come up with, you know, new animations without the arduous task of hand animating all of the bones and all of the fur. So this was a group of researchers at I believe the University of Manchester in England, and one of the researchers ended up working at Adobe. I'll just skip through this a bit. So here you can see that the icons at the top are sort of like what the neural network or the deep learning system thinks is the right animation to show at the right time. And then it figures out how to blend them to create this like smooth motion so it looks lifelike. So then, you know, the natural evolution of that was like, how would this look in augmented reality? So what if that wolf or four-legged character was interacting in your environment, kind of like Pokemon Go? And so this was so I worked with the researcher to implement some of the UX and code behind this to be able to control this puppy on a screen with your finger, so you can sort of define where would the puppy go, and it would figure out the path, and then it would work on a mobile device instead of some big computer, and you could, you know, have the puppy run around in your real world. And this work was actually presented at the Adobe conference this week during the CTO's keynote, as an example of deep learning and artificial intelligence work that Adobe's doing. So Project Arrow is Adobe's new augmented reality application, and you can actually go to this website and download it and try it out as of this week, pretty much. This is a picture of the CTO showing the work on Monday in front of a large group. So it's pretty exciting to see, you know, a prototype go from, you know, a research paper to a collaboration to, you know, something on stage at a big conference. So I'm going to just do a little demo of the app on my phone. Not that particular feature, yeah, but the app lets you bring in 3D assets or Photoshop files and place them in the world, and you can share them with other people. But you should check it out. It's called Arrow, Project Arrow. So this is what Project Arrow looks like, and this is a special build basically that has this one feature. So you open up the camera and you scan your environment, and then the system sort of tries to figure out, okay, well that's where the ground is, and then, you know, this is where the keyboard is, and then you can anchor objects to that surface. So if I tap on this, it's going to create a composition, and then I can bring in this target, and that's going to show this puppy. And now, wherever I kind of move this target, the puppy kind of follows it around. And there's some sort of like interesting UI, like there he is. I believe it. So this was actually motion capture data collected from a real dog with a bunch of markers. I believe the dog's name is Virgil. And then on the device, there's a deep learning model that kind of figures out which animations to show. And now I put him too far away. There we go. So if you move the object a little faster, he'll kind of run or jump. And this is like a very early prototype. It's just like a couple of weeks of work, and it's mostly the researcher's work, and then helping him out how to integrate it into the code base so that it works within the product, and just coming up with like UX around it, like making sure the shadows, are always showing appropriately, and then there's a little visualization of like what the path will be. That's what those white dots that kind of fade in and out. And, there's certain considerations, like you don't always want to see that path, but you want to see it at certain moments. So those are some of the considerations that you come up with in your prototyping software. And yeah, and that's about it. Thanks.